In the previous lecture, we have discussed the covariant fundamental tensor G sub ij. In fact, this tensor finds its application in the general theory of relativity, and on the same line, the another fundamental tensor of second rank, which is actually a contravariant fundamental tensor of second rank, and that is G super ij. This also finds its application in the general theory of relativity. In fact, in the forthcoming lecture, when we will finish the lecture on these fundamental tensors, then we will separately discuss the importance of these fundamental tensors or the metric tensor in general theory of relativity. But in this lecture, we will discuss in very brief the meaning and the important properties of the contravariant fundamental tensor, this G super ij. Basically, this fundamental tensor G super ij is defined like this. You define this tensor as cofactor of G sub ij in G over G. In fact, here this G is what? This G is actually the determinant of this G super sub ij, not super, G sub ij. That is the fundamental covariant tensor Gij. Its determinant is has been written by this symbol G. It means we can say that this G is simply equal to the determinant of G sub ij, or you can say that this determinant will be equal to, in n-dimensional space, these are the elements of this determinant G11, G12, G13, so on G1n, and G21, G22, G23, so on G2n, and similarly Gn1, Gn2, Gn3, so on Gnn. This is actually the meaning of this G. So remember this basic definition. I hope you have a concrete knowledge of the theory of determinant and matrices. And definitely in the theory of determinant, you have find the cofactor of a determinant. So I hope you can evaluate these cofactors of Gij in the determinant of this Gij in any problem. Now, in the previous lecture, you have seen that the covariant fundamental tensor Gij, we have seen that this Gij, we have seen in the previous lecture that this is a symmetric tensor. Gij is symmetric. This is a symmetric tensor. That is, we have seen in the previous lecture that this Gij is equal to G sub Ji. Now, since this G sub ij is symmetric, so this result actually implies that the determinant of this G sub ij, which we have assumed that it is equal to G, this will be also symmetric. This will be also symmetric. Also symmetric. And since this G, which is actually the determinant of G sub ij, is symmetric, so it further implies that the cofactor of this G sub ij in G is also symmetric. So this implies cofactor of G sub ij in G is symmetric. Every statement is linked with its previous statement, you can see here. And once you say that the cofactor of this G sub ij in G is symmetric, it means that this statement implies that this G super ij will be also symmetric. This is also symmetric. So finally you can say on this basis that this contravariant fundamental tensor G super ij is also a symmetric tensor. So we conclude that G super ij is symmetric, and if it is symmetric in the indices I and j, you can say that this G super ij is equal to G super ji. Now we will also see that this tensor is also a second rank tensor. But for proving that very important fact, let us consider an arbitrary contravariant vector, and this contravariant vector we let us consider this is T sub super I. So now consider, let T super I be an arbitrary contravariant vector. Contravariant vector. And if you consider that this T super I is a contravariant vector, then by the quotient law, which we have studied earlier, you can write a covariant vector in this manner. You can see by quotient law, by this quotient law, you can say that T sub j is equal to T super I G sub ij. We can say this. This is in accordance with the quotient law. And this Tij is what? This is nothing. This is simply an arbitrary covariant vector. This is an arbitrary covariant vector. Arbitrary covariant vector. Now, to prove that this tensor is also a second rank tensor, let us multiply this equation number 2 by the contravariant fundamental tensor, that is Gij. So now multiplying equation 2 by, let us say, G super jk, we get what we will get. You can see here, this will be actually equal to T super jk times Tj just we have taken the inner product, and that is equal to what? This will be equal to G sub ij times G super jk times Ti. You can see I have just multiplied by this tensor to this equation 2. But what is this product? You can see here. But G sub ij times G super jk. This can be written as G sub ij, but see this tensor, G super jk. See the basic definition of this contravariant fundamental tensor G super ij. This is cofactor of Gij in G over G, where G is the determinant of this G sub ij, you know. So from that equation 1, instead of this G super jk, you can write what? This will be equal to cofactor of G sub jk in G and divided by G. And this is equal to Kronecker delta Ki. This is on the basis of theory of determinant. You have studied theory of determinant, then we see there that this product Gij times cofactor of G sub jk in G over G, this is equal to actually delta super k sub I. This is Kronecker delta. So this result I have written on the basis of the theory of determinant by theory of determinant. Theory of determinant. So finally, you can now see, since this product is equal to this delta Ki, so we can write this this equation, that is, this product can be written like this. So therefore we can write G j super jk Tj. This will be equal to what? This will be equal to T I times delta, in fact then this will, yes, Ti times delta Ki. And when this I is equal to K, then you can write this as T super K when I is equal to K. I is equal to K. And in this condition, this Kronecker delta Ki is equal to 1. This is equal to 1. And so this is actually a very important result. You can see from this result that as G super ij raises tensor indices, just as the G sub ij lowers the tensor indices. And finally, from this result, we can conclude a very important fact. And what is that fact? You can see the inner product of this GJK with an arbitrary covariant tensor Tj is equal to simply this T super K, which is actually a contravariant vector. So by the quotient law, you can say that this G super Jk is a contravariant tensor of rank 2, you can say. So this conclusion, for your convenience, I am writing here. So we can see here that the inner product of G super Jk and an arbitrary covariant vector Tj yields a contravariant vector, and hence by Quotient law, G super Jk is a contravariant tensor of rank 2. Now we can also see a very important property here. You can see that the inner product of G sub ij and G super Jk, this is equal to, in fact, this much. So see this, as we have seen that G sub ij times G super Jk, yes, super Jk, this is equal to G Ki. Now if K equal to I, then what will be our result? Result will be Gij and Gji equal to Gii. Actually here I have replaced this K by I, but you know, sorry, this is not G, but this is Kronecker delta. This is Kronecker delta. And so this will be also the Kronecker delta. This is delta I. But you know that Kronecker delta II, this is equal to 1. This is equal to 1. And again, you can see that we have seen that this contravariant tensor Gij is a symmetric tensor. So you have seen earlier that this G super Ij is equal to G super Ji. So using this symmetry property of this tensor, you can write instead of this G super Ji, we may write G super Ij, and that is equal to 1. And therefore you can see this G sub Ij is equal to 1 over G super Ij. And what this result implies? You can see that this result implies that the contravariant tensor of rank 2, that is G super Ij, is just the reciprocal of the covariant tensor of rank 2, that is Gij. So you can say that this tensor is reciprocal of Gij. So this result implies that G super Ij is reciprocal of G sub Ij. And that's why we call this tensor as conjugate metric tensor. So it is called conjugate metric tensor. Conjugate metric tensor. So I hope you have understand the definition and the important properties of this contravariant fundamental tensor. In the next lecture, we will see the mixed fundamental tensor and the importance of these fundamental tensors in general theory of relativity.